Okay, we should be live. Hi, everybody. My name is Nica. You remember my face. And with us today, we have Srikanth, one of the engineers at Signas. Say hi to the people. Tell us what you do for Signas.
Hey everyone, my name is Srikanth. I
Tell
work
us what you do for Signas.
as a engineer at Signos. I'm also one of the I used to be one of the maintainers of OpenTelemetry, and now OpenTelemetry Python specifically, and now I'm part of the team that manages the OPAM. Yeah, that's about.
And today we're not talking about like Signas tooling or anything that's specific. So if you are just somebody who's excited about OpenTelemetry, you're watching this video, it's this is all going to be for you. That you use Prometheus, you use any other kind of metrics backend. If you're reporting your OpenTelemetry data into Datadog or New Relic, this is all going to be useful stuff. So don't stress out that we're bad. We're just very grateful to Signas for giving us the space and the time to have these kinds of chats. And speaking of which, if you are interested in OpenTelemetry and you're in the Bay Area in the United States in California, we are going to be having a meetup on October 4th, where also we're going to be talking about the OpenTelemetry API and some other instrumentation concerns. So you'll see the link listed down below to join us for that. So do come check it out. But what are we here to talk about today? Let's talk about it.
Yep.
So this is like a quote from the OpenTelemetry docs, and if you go beyond like this quote and read further, it starts getting really specific about like where the API is used and where the SDK is used. But I always felt like it kind of got me. I was like, okay, wait, all right, yes, this would be API, this would be SDK, this is the API. And you gave this talk at our in-person meetup, and I was like, oh my gosh, more people need to see this, because if I'm confused about this, I know other people must be too.
Yeah. Shall I take it up?
Yeah, let's go ahead and get started.
Yep. Yeah. So like for anybody who is getting started with open telemetry, you will be like the common question that people the get ask is like, what is it open telemetry? What does it do really? And there's no clear one thing that it does specifically. It does number of things. So here the what you see here is the like how OpenTelemetry describes itself as it's a collection of APIs, SDKs, and tools. That tools is a broad overloaded term that contains number of other things. You use it to instrument, generate, collect, and export the telemetry data to some the telemetry backend. So there are a number of concepts that if you are somebody who is just getting started, you like what is even API, what is SDK, and what does the tools sections contain. It can be overwhelming to overwhelming, and it's sometimes unclear what is like what is that API or SDK, what are they doing, and why is it specifically, like why is there a need for an API to exist. So we'll get into those details. So there are there's a lot of things to cover. Like there's a metrics API, there's a logs API. But today we're specifically looking into tracing, since that in itself is a bigger area to cover, and we will in upcoming sessions we can get into more details as well as we yeah.
And yeah, absolutely. And I think it makes sense to start right with tracing, right? This was it was the open tracing project, right? So tracing is often right where we begin when we're thinking about open telemetry. And not just because you're stressing me out, if you don't mind turning off your notifications, I keep thinking I'm getting a chat and going to check it. Thank you so much. If it was that brush pick Slack sound, I'd be nuts by this point. I'd be like, oh god, I have something I have to answer. But yeah, it's great to be starting with traces first. Please go ahead.
Yeah, give me a second.
No rush. We see some people joining on the live stream. Thank you so much for checking it out. If you're watching this recorded, which I know most of you are, we'll have links down below, and do feel free to add questions in comments down below to the recorded version, and we will get back to you right away with answers. Really appreciated that from people who left questions in the last few videos.
Yeah, coming to the APIs and SDKs, these are the two things that you will hear very often, because as an end user, it's something like, okay, so while there are lots of things that are happening as an end user, what you will most likely work with is the API part and the SDK part. You instrument your application with the API, and you substitute it with the one of the SDKs, while there's only one reference SDK, the official OpenTelemetry SDK. As a user, you will be mostly working with the APIs. Yeah, let's get into the. So so when you hear an API, like what does the OpenTelemetry API contain? So it's basically it's OpenTelemetry API is essentially a set of abstract ideas, abstract operations defined on a span. Like, let's say if you are recording, if you are recording something, like if you start span, what are the set of operations that you can perform on a span? So you can as you record the span, there are a number of things that you may want to do. Like, let's say you start a span, you get some user ID, you want to set an attribute, or let's say while the span is being recorded, there's a chance that some exception happens, and it's important that you capture that exception, so that you can later see what the exception stack trace and what the context of the under which context the exception has happened.
And just in case people are totally new to tracing, right? Span has become this totally standard term, right? It just means any kind of span of time, but then it has some attributes to it, right? Generally, it has what service it's occurring on and what method or what is actually being executed. Well, actually, you tell me. Is that a good definition for a span? That's what I always think of it as.
Yeah, it is certainly, you can say that, so how do you, so it like it's a it's up to you how, like, so it can be as granular as, like, instruction, or it can be as granular as a function, it can be as granular as, like, over entire API call. So there is no restriction that, so it you want it to be represented a certain kind of operation. Okay, so I did perform this operation and I want to track this operation. So that's where you introduce a span. But and that span can be like, it depends on the granularity level that you want to. So let's say you make a certain function call, and that every function call can be a span in the call chain. But if that's something like in a overhead for you, you can only start a span at the parent level operation. So you want to, it's a unit of operation, but that unit of operation is specific to, like, each use cases. So it's so there is no like, nobody's making you to write only that, okay, it has to represent this level of granular. It's up to you as an end user to or decide what level of what does an operation mean to you.
Yeah, no, this is really true, and I missed it from my version. Is that like, it might be a function call, it could be an individual operation, it could, I don't know, you could have it be marked with a particular step of bytecode or a specific memory instruction, right? It can be any level of granularity. It's covering some span of time, and it can be all the way from just like request.handle, right? Took this long. To and then the other part of that is, well, we have this idea, and of course Kubernetes has this idea really basically of like a service, right? And like a service exists, and we have like a service name, but that too could have any level of like granularity to it, right? It could be that we're talking about very tiny little microservices and dozens of little services handling the steps on a trace, or it could be just the entire system marked this, didn't report the span until the entire system, marked it as complete. And so all of the components in there are just inside of one giant time span. Yeah. So really appreciate the clarity there. Thank you so much.
Yeah, and when you work with when you're working with a span operation, right? So you want to, okay, so this is the unit of operation. You know what you want to monitor when you want to track, and you start the span. So there are a number of things that you want to do as a while that are. So let's say if you are looking, let's take a function call as something that we are interested in, monitoring. So you start a span for that function call at the beginning of the function call. There can be number of things that can happen during the function call. So let's say you make a call to the external API, you get some user ID back, or you make a call to the database and you get some data back, right? And you want to so the richness of the tracing is because of you can have high cardinal values and have some very specific context. Okay, so usually there are certain kind of issues that only show up in very specific scenarios. Having a contextual information associated with that operation that the function is performing helps you in resolving the issues faster. So there are number of as the span is as the span is being recorded and before it terminates, right, there are number of, if let's say if there is some exception, so the first like there's a set attribute. So what does set attribute does is, so you attach some extra pair of key values to the span. Okay, so span has started at a point t1, and I okay, now I got some information back from the database or somewhere some other means. You add a attribute to the span, and then there's an add event. So basically this add event is, okay, hey, I have this during this function call I have this interesting event that has occurred, and it will be used for I'll be using this later in time when I'm looking at a context. So then this add event can be useful. The event can be, okay, so this is the event name, and this is a set of attributes associated with the event. So the event, not to be confused with the attributes of the span, so they are different. So the set attributes on the span are representing it for the whole operation. It could be that you have n number of events within that span, and each event can have its own set of attributes. Let's say you get a call. So within this function, let's say you have a DB call and you get a data back, and something of interest, you get back the data and you perform certain action. Then you record that within the sub action as an event, single event, and it can have its own set of attributes. And there's a status. So let's say while you perform the while the span is being recorded, let's say something happens. Like take the DB examples again. Let's say you get an error back from the DB, and you want to record and say that, hey, this is a unsuccessful operation. You want to have some way to specify that this was an erroneous transaction, like an erroneous operation, or it was a successful operation. So the set status is a way to tell the like it indicate that, okay, was this span successful, like or was there any error associated with it. And when there is an error associated with it, you can say, okay, so this is the error message as a part of the span status message. You can say, okay, so this is the code and this is the detail that is associated with this span status, and that represents the whole span status. Let's say you have certain exceptions that are not really an error. So let's say there can be certain exceptions which does not mean that the end user seeing it as a error. So it's a expected exception, and you still want to record those exceptions. And there in those use cases you have something called record exception. This exception takes the whole entire stack trace, like what is the exception name, what is the type of the exception. Let's say you like if you take Java, there's a IO exception. So the type of, it takes the name of the exception and type of the exception and the when did the exception occur, and the whole stack trace of this, so that when you see the exception, when you see the when you look your data, visualize your data in some tool like Signals or something else, when you see this error span and list of exceptions, it makes you to follow, okay, so this was the set of attributes, and this led to this exception for this user. So that's how. So this API helps you to, okay, what can a span do. So a span, you start a span, what does the whole the entire list of actions that you can do on span is what the API means. So let's say anybody, some like if I were to say that, okay, so I want to add a new set of operation, like let's say I want to perform something that's already not there here. The first thing that to start with is, okay, I need to get this added to the API. So this is the set of things that a span supports, and this is what is commonly referred to as a API, OpenTelemetry. Like this is specifically we are looking at a span. What does the span API represent? Span API represent this set of operations that you can perform. Yeah.
Yeah, so I think definitely makes sense, right? You want to be able to raise exceptions whether or not the request like completes successfully, right? Like if you're loading, I don't know, the user's friends in a list and that comes back with like invalid request, we still want to load their other profile page, right? We don't want to stop the request or return 500 to the user. So, you can raise multiple exceptions within, right, one request. And I didn't actually realize that like an exception could be part of one. I mean, it makes sense, but it could be part of a particular span. It's not just like an exception on the overall request.
Yeah, exception under the hood, it's actually, so it's like
Or I said request, it should be like, it's not an exception on the whole trace, right? It can be tied to a span.
Yes, correct. And the record exception it's more like a syntactic sugar on top of add event, so it basically gets added as an event on the span. But yeah, it's helps clean. And let's go back and look at the, so now you have seen this like interface, right? So this in language of your choices, if you look at what the API package does, it provides you a list of abstract classes or interface definitions. What we have looked at is a span, and there is a sampler API, there is number of other APIs, there's a tracer. Tracer can start start spans. So the API is basically a set of operations that you can perform, and the what you can do is limited by this API only. So let's say we want to do something on, let's say you want to do something else, it must be added to the API before you can do anything. So your use cases should be, so anything that's not solved by your use cases should be coming into the API fast. And this API is just set up a abstract classes with the no-op implementation. By the no-op implementation, what I mean by that is, if you just have a API installed, there is nothing actually happening. Let's say if you start a span and you set attributes, nothing is happening in the background. It is ignored. So why this is done is there's a long reasoning, because so eventually the goal of the OpenTelemetry is to make sure that every library, third party library, framework, web framework of your choice, to make the convince the authors of these libraries to get their code instrumented, so that you don't have to install additional instrumentation libraries. Today you need to install like n number of instrumentation libraries via auto instrumentation. But ideally the state OpenTelemetry hopes to be in, eventually, is that you don't have to install any instrumentation library. It's just that the library, the third party library or the web framework that you are using already has a built-in native OpenTelemetry instrumentation, so that you don't have to find a hacky way to get the instrumentation working. And the concern with the and for the people, as a as a author of the web framework or somebody, I will not be inclined to take a dependency on a package that is big, that is doing a lot of magical stuff behind the scenes, right? So the idea behind this, having an API package doing nothing, is that, so that it is transparent to the author of these frameworks. Okay, you are giving me, okay, the API in itself is doing nothing. It's a simple you have the abstract classes and there is a no-op implementation which does nothing. If that makes a convincing case for for them to say that, hey, please adopt this, please instrument your code natively with the OpenTelemetry API, so that the people do not have to write a separate instrumentation library. And and the it is built in such a way that so you can always have a like, so API is not producing any real spans, like any real data, if you just have an API package, when it is substituted by SDK, right? So the third party library author, a library author or a framework author can instrument their code with this API package, which is not doing anything, like it's not producing any real spans, it's just a no-op implementation. Where the here comes the SDK. So when does the actual span gets produced? So if you do not have any if you have not any substitute, like if you have not installed any SDK, everything is a no-op. But as soon as you install a as soon as you install a SDK, there will be some proxying between. So initially it is a no-op, and everything is a no-op. But if OpenTelemetry detects that there is a SDK installed, what it does is it is going to proxy the request, proxy the operations that you do, and produce the real span. So now if there's a SDK installed, instead of ignoring whatever you're doing with the set attributes or add event or record exception, they will be proxied to an implementation which actually does recording them. So let's say you do the set attributes, it maintains those set attributes, and this SDK is also responsible for, okay, so you are starting these many spans, like who is going to, are they emptied right away, like how are they doing? So the SDK is also responsible for the idea of, okay, idea of processing them, maintaining a queue internally and processing them, and then exporting them periodically as soon as they finish. So that's where the SDK comes in, and the role of the SDK is like generate the actual spans and then process and then export it to the destination, like some network destination which accepts the OTLP. Yeah, let's get into the tools that we looked at in a last couple of last slide. So we discussed we briefly discussed about the API, and then there's SDK. Now, okay, so you generate this you're generating this spans. Now what happens? Let's say you want to do how are they sent, like, okay, so you're saying that they get exported to some destination. When there is a net when there's a when you have to send the data over the network, you need to have some wire format, right? So that's where the OTLP protocol comes in. So OTLP protocol is essentially a message format structure for the data that is getting generated by the OpenTelemetry instrumentation. So the OTLP protocol dictates, okay, so this is how the message format should be. This is what it has to adhere to. There's a contract between the instrumentation that is generating the data, and then there is another other side of the network destination is the receiver, which is getting the data so that it can post process the data and send it to some write it to some database. So
Yeah, things like
that's
stitching together a trace and the other components that have to happen after a trace is captured or after a span is captured.
Yeah, and then we have a semantic conventions. So as you so the entire, like the this I think is the most beneficial thing out of the open telemetry. So they standardize the how you record certain things. Let's say like there's a set, we have seen that the span has an API called set attribute, and it is accepting a key and a value. Let's say you want to record a DB statement, like let's say you want to record a DB query, right? How would you do that? Like different people have different ways of writing the, okay, what should be the key? It could be db dot statement, it could be db dot query, it could be simply statement, or it could be sql dot statement, it can be anything. What semantic conventions does is it dictates, it says what should be the key. So for certain kind of traditional operations which are very common, so it says what should be the how should it be represented. Let's say if you are if you want to record a DB statement, it should be DB dot statement. So that is the key that should be, value should be representing the real statement. And so see, it has a bunch of these semantic conventions that says, okay, how do you Like if you have a network address, how do you represent that network address in a key? So these semantic conventions dictate how do you what should be the key, and how should it be represented. If you take for example like host, if you have used the host matrix, right? So there's a something called host at name, so that represents a host, host, and there's a host dot arg, which it represents the architecture of the host. So by making these by making these semantic conventions, as if everybody follows these semantic conventions, right? You have a certain standard that is enforced, and it makes you to correlate the data really well. By that, let's say if you're using the let's say a span is recording, and it uses the host at name, and then there is a actual host, the CPU matrix that is exported, and it is also using the host name. So by having the same key between the metric telemetry and the spans that you are emitting out of your instrumentation, you can later correlate the, okay, hey, what was the, for this specific host name during this span duration, what is the CPU? So it makes it easier for you to correlate the data, and you can do number of things makes by standardizing that. And then we have instrumentation libraries. So so if the API and SDK are there, it does not make it easier for the user, you as a user, to get started with OpenTelemetry. You it's if you are take a web application developer, somebody who works majorly on the building some web interfaces and then having some backend language. It's there are a number of frameworks that people go with, like there's a Django, there's a Spring Boot, like so having some library which gives you the ability to, like, which automatically exposes some data. So there is a, so what do you want to get started with, like have, like if you are serving a REST API service, you can minimum start with, okay, so these are the endpoints, this is the give me the make sure that there's a trace exists, span exists for each operation, and then record a request latency for them. So these instrumentation libraries provide you a out of the box experience that makes it easier for to get started with and have some data coming out of your application. And we have a auto instrumentation. I like to call it as auto magic instrumentation, because it's behind the scenes. It is doing the some magical stuff that makes it happen to, while you don't change any code, and you still get some traces out of it. So the way that's done is usually the number of techniques, like it is specific to each language. Sometimes it is a middleware, so you write a middleware that every request goes through that middleware, and so that you get the data out of it. Sometimes it is a monkey patching, so you imitate the actual original function, and then all your requests go through this monkey patch function, and you get a data out of it. And then there's a bytecode manipulation in Java, like Java has a great support for that instrumentation. So
Yeah, a
that's
lot
where
of people
the
wonder why Java is the best currently for like auto instrumentation. It's like, well, because Java is, the JDK is set up for that. The JVM is set up for that from the start to allow you to do this kind of bytecode manipulation.
Yeah, right. And it's the, like, yeah, among the all the OpenTelemetry, like auto instrumentation, like Java is still the best. There's nothing that beats them.
Yeah, if I had to list like the like top 2 or 3 like misconceptions about OpenTelemetry, if the first one is that there's like a dashboard and data like storage system is part of the project, which it is not. That's a big one. But then another big one for people who haven't used it at all is they think that adopting OpenTelemetry means going into every single one of your function calls and like adding some call to say like, okay, originate a span here and originate a span here to create a trace. But it's like, no, like most of the time, auto instrumentation just works and you can just grab whatever you need automatically.
Yeah, and then we have a collector service. So collector, I call the collector service as a Swiss Army knife. Like it does. So there are a bunch of receivers, and then there are processors, and there are exporters. So this processor helps you in how there are, like, let's say you want to perform certain certain processing logic, post and push it, so that certain processing logic but you don't want to keep it in the application. Like if you keep it in the application, your application, your user is getting affected. So this collector service helps in doing this processing stuff outside of your the process that your user is facing. And this can do a lot of things. Like it can change the way you write the attributes, drop the certain metrics, reaggregate the data, and enrich the metadata. So and there is a processor for each certain, like if you have a certain goal, if you want to redact the data and you have some certain sensitive information, you want to get rid of it, or you want to enrich certain information. If you're running in a Kubernetes environment, you want to enrich with the pod ID, pod name, etc. So there's a processor for each use case. Like let's say you want to do some certain specific thing, there's most likely a processor for that, and you can put it as a part of the pipeline. So it's optional. Like you don't have to, not everything has to go to every processor pipeline. So you can have a customized processor pipeline, only only add the things that you are interested in. And we have a operator, OpenTelemetry operator. So this the entire goals of this operator project is to make it easier how make it easier to run OpenTelemetry in a Kubernetes environment. Let's say if somebody has the Kubernetes cluster already, how do we do, what can we do to make it easier for them to run instrument and send the data? So the operator also does use auto instrumentation, that it changes the runtime behavior under the hood, and gets the telemetry data out of it and sends it to the backends. Yeah.
Nice.
So this I want. Yeah. Good.
Oh, I really like getting this map. I think it's so critical to like just review like what's in and out of the project, and also separating out the collector from the like instrumentation, because that's not, if you're coming from like a closed source or SaaS observability tool, that's not exactly how it works. And so it's really good to have that clarity.
Yeah. So and this is very dense. So the as brought up earlier by Nica, so the goals of like the OpenTelemetry is only responsible till you export the data. It is not a storage system. It does not provide you anything about the storage. It is up to you where you store the data. And just because that you can trace everything doesn't mean that you should trace everything. So there is, you want to control the volume that your application is generating, right? That's where the collector service comes in. Okay, so is this like you can do sampling and certain techniques to drop the data or reaggregate the data. So here we have a simple message structure. We want to show it for the logs. So so how are let's say if you take a log, so your application is sending logs to some OTLP receiver. How do they look? So this is how they look. So you have a resource. The resource here represents a entity that is producing the data. It can be a pod, it can be a container, it can be a physical host machine. The resource represents the entity that is producing the telemetry. And you have a scope logs. Within the scope logs you have a log records, and the log record has when time Unix nano, like when did the log recorded, and when it is observed, what is the severity of the log. It's like log level, and what is the severity text, and then you have the log body attributes. So this is when you hear OTLP protocol, this is essentially what it's being referred to. What is the message format that is used when the when you're transporting the data to somewhere else. And this is slide that I wanted to show to give some kind of overview about the semantic conventions. If you look at the DB, like this is the attribute, and what should be the, so the semantic conventions say that, hey, if you want to represent a certain how do you represent a certain thing, how do you what kind of attribute do you use, what type should it be, and what does it indicate. So let's say there's a db.system attribute. It indicates what's the database system that you are using. So it will be key will be the attribute will be db.system, value will be MySQL or Postgres. Like so these there will be set up these enumerated databases that you can add to them. and then there is a server.address. So this is like, say, let's say if you are making if you are making a call to that's outside your application, it can be database, it can be external HTTP endpoint. So how is that another the service that is running on the other side of the network socket is represented? So server.address. So by having these semantic conventions enforced, it makes it easier to, now you have a single standard, and it makes it easier for to correlate, and and not worry that like since everybody is going to adopt these semantic conventions, when you move from the one vendor to other vendor, you don't have to worry how, like, let's say when you carry things like, okay, if you got used to db.system, even if you go to another vendor who supports OpenTelemetry, it will still be represented as a db.system. That's among the benefit among others. And this is one Node.js example how the instrumentation is done. So here you have a HTTP instrumentation and the Express instrumentation. Express is is the most popular, one of the most popular libraries that's used in the Node.js ecosystem.
And here we
And
get to like if you conceptually struggle with like how automatic instrumentation like works, like how does it do what it does? It's not it's not some very generalized like computer science approach in general, right? Like it doesn't create a middleware on every single function. It's like, hey, if you're using Express, right, we know how you handle an incoming request, right? And so therefore we should be able to kick off like, okay, once you kick off a following function, instrument it in the following ways. And so yeah, it works by virtue of knowing what frameworks you're using and knowing how those generally like gather, emit when a request is probably starting, when it's finished, and thereby calcing that to a trace.
Yeah, and it is, and and this instrumentation library has to be written by someone. Like there's a possibility that you are using certain library which does not have instrumentation, and you will not get any traces or spans out of it. So by knowing that instrumentation like library details in and out, so you can create an instrumentation and make it part of the whole request trace, emit the traces. And there is a auto instrumentation, like we said. Auto instrumentation is where you don't have to make even a single line of change. And then OpenTelemetry has every language has to certain extent has some support of the auto instrumentation, where you, let's say you as a DevOps engineer or SRE who wants to get started with OpenTelemetry and want to convince your developers to get started with this, right? So this is where the auto instrumentation comes in. If you were to so let's say if your project today runs with the Flask run port 3000, you can change the run command from that command to OpenTelemetry instrumentation hyphen traces exporter OTLP, and then the regular run command. By doing this, what OpenTelemetry does is it does some stuff in the backside, by instrumenting by looking at the your libraries that are installed in your virtual environment, and instrumenting them and setting up a OTLP backend. And this is really good to get started with it, because you don't want to change any code right away, but still want to see the value getting out of it. So this is where auto instrumentation is really helpful. Yeah, and how does the instrumentation work? There's a middleware, there's a monkey patching, like the techniques that we discussed. And if you as a user have some library, whether it's an in-house library or it's a third-party library which is not instrumented, but you want to instrument it somehow, so what you will, so by knowing that these are the techniques that are used, it makes it so you can write your own instrumentation library for the third-party library or your in-house. So this is one of like among one like one of these techniques will fit into your use cases, how you get started writing your own instrumentation.
Something I wanted to ask you about this is that, something that's very active in the community is talking about how, in the future, we'd like to see more sort of standard libraries saying, hey, we already have OpenTelemetry instrumentation like released as part of that library. And I apologize, I didn't look into this before this call, but has that happened yet? Like, are there libraries out there that are like, hey, this already has
Yeah, so
OpenTelemetry
there
API
are
calls within it?
yeah, there are libraries, but they are not really that popular, as in, so if you take the Jenkins, right, Jenkins does that, like Jenkins automatically emits the traces, and there are Apache, there are some libraries projects in Apache that emit this. And if you take ClickHouse, for instance, like the database that Signals leverages, ClickHouse also emits the like, let's say if there is some queries running and it is doing some work, and ClickHouse adopted this OpenTelemetry into their code base, and ClickHouse emits the OpenTelemetry traces. And every language, there is a slow progress, but there is still a progress. Okay, so eventually, hopefully, there will be some day where you don't have to write these instrumentation libraries, and just get the spans emitted out of the library natively.
Got it. Yeah. I
Yeah,
mean, I think, we're not quite there yet, right? To open telemetry
right.
being like universal in every place. But this change is fast approaching, right? Like you're seeing like
Yeah,
a ton of engagement. And I would say like, not every system everywhere like concerns itself with observability at all. So it makes sense that this is not going to be universal, probably ever. But yeah,
yes,
I do expect to see it grow in the next couple of years.
yeah. And you as an end user, what is it you usually interested in? These are the these are the areas that if you're an end user, what you mostly care about, whether do you have an instrumentation library for the framework that you are relying on, and once you have the instrumentation library and the data is coming out of the instrumentation library, can I drop certain data, enrich certain data? Let's say you have a certain health check endpoints you don't want to coming out of your library, right? Are there a certain specific endpoints that you don't want to uh, uh, yeah auto instrumentation endpoints, some certain things that you don't want to send it to further, like you just want to get them to be dropped, or you want to enrich certain things. So that's where the collector service comes in. So you can have a certain you can have a processor that reaggregates or that drops the data, like filtering, basically filtering those health checks and points that are unnecessary for you. So these are I would say these are the two areas, like if you want to uh, get started with OpenTelemetry and have a decent success in implementing in your organization, get having some decent understanding of instrumentation libraries, and having knowing the collector, how does the collector work, and what are all the process does it have, really helps. And if you are like, if see, there's a chance that you have a certain in-house libraries, or you have a third party library you want to instrument yourself. This is where then you become a instrumentation author. So this is where the API and SDK come into picture. So you need to use having certain understanding of whole everything about, okay, so you instrument it. Now that there's something called semantic conventions, when attribute your spans to attribute your spans to, like, enrich that, have some metadata associated with the spans, that, hey, this is the attribute that I should use. And knowing that, okay, so these are the operations that you can perform in a spam. Now that, hey, there's a way to record an exception, there's a way to add an event, and there's a way to set attributes.
And
So
I,
that's
I hate to
helps.
interrupt, but we have just a question in chat, and it's not really it's a little left field. So just to give us a moment, Niraj asks, what does Signos do? Let's have OTel auto instrumentation enabled. Is it a visual tool or more than that? So we covered this a little bit right at the start, that the OpenTelemetry project is really a project that goes all the way up to data storage and visualization. So that can be handled in a number of ways. There's a number of closed source solutions or SaaS solutions, right? Like the existing kind of older APM tools have some way to accept OpenTelemetry data. How they display it is kind of their choice. So, if you're a diehard, New Relic user, you can send OpenTelemetry data into New Relic, and they will let you view it somehow in general. But then there's open source tools that say, hey, I want to, report and store that data. And so, Prometheus and Grafana are one of those solutions. There's multiple others, and Signos is one of those. Is a free and open source tool to store and let you visualize the data. Anyway, that's the answer to that. But that not this is really not a this is not a pitch for Signos. We're not going to look at any Signos stuff, but this is a general overview. But yeah, you'll see that all of this tooling stops at the point of like, how do you store and visualize this data? That's not part of the OpenTelemetry project. So yeah, so one of the things that you'll hear from the SIGs is like, well, we did not actually want to go out and like compete with the APM tools that are out there. We wanted to cover the instrumentation, the connection of that data, and the ways that that data is reported, but not how it's stored and visualized.
Yeah, that's all I have for the presentation. I hope.
Oh, sorry. Oh, no. I was like, we got to interrupt and answer a question. And then the next slide was Q&A. Sorry about that.
Yeah, I'll be happy to answer any other questions you.
But yeah, folks, if we have questions, feel free to drop them in the chat. Sorry to immediately interrupt to answer one. But, Srikanth, you got to come back to dive a little bit into some of these like instrumentation techniques and how data is reported, especially with looking right now at the Go project and trying to do this eBPF instrumentation is really fascinating.
Yeah, so so we covered it in a briefly, but if you pick any single concept, there is a lot more detail that can be covered on its own. But hopefully this was helpful in giving you a certain high level idea, and then in the next sessions that we organize, we can get into details of each of them.
Fantastic. So Deepak asks about what are some of the best practices for instrumentations. This is actually a pretty good question. It's like, how do we get started? I would definitely say just try using like an auto instrumentation library. I think one question I would have is, do you ever feel like you would be advising someone to like turn off parts of auto instrumentation or try to configure or alter those settings, or is it really just, hey, you turn on auto instrumentation and then add what you need beyond that?
So if you are already Neeraj is asking, is there a way we can pull the data from the AWS managed services traces from X-ray and pull into Signos? It is if you have the instrumented your applications with the X-ray, then it's difficult. But let's say you have the instrumented, if you have instrumented with OpenTelemetry and currently sending it to the AWS managed X-ray, like you chose AWS X-ray as the tool that you want to see visualize, use the tool to where you store the data, then it is possible to switch to the Signos immediately. But if you instrumented your code itself with the X-ray, then it's not possible today.
Yeah, so I will say, for all these Signos questions, since Signos just receives data from a standard OpenTelemetry collector, it's really just, if you want to know the answer for that, it's really just what can you do with OpenTelemetry. Now, there is the AWS distribution for OpenTelemetry. I believe that's going the other direction, right? That's like ingesting OpenTelemetry traces and displaying them in X-ray. I don't think there's a tool, right? I don't think there's the capability to like send an X-ray trace and have it be consumed by an OpenTelemetry collector. I could be wrong on that. Correct me, Chad, if I'm wrong, but
yeah. You can however receive so there are a number of AWS specific receivers that has AWS container metrics, AWS. So these receivers help you to get the data from the, let's say if you are some user of the AWS services that you rely heavily on, OpenTelemetry has these receivers that makes it easier for you to send the data to. So you may be using the AWS managed CloudWatch or etc. So with this help of the OpenTelemetry receivers, you should be able to easily send the data from this CloudWatch or container metrics, etc. Everything to the Signos easily. Bhupesh asks, how is Signos different than Grafana?
We're going to skip that question. They're both tools to visualize your OpenTelemetry data. We're not going to pitch. We're going to distribute this as like an OpenTelemetry webinar. So go check out signos.io. but we're not. I'm going to tell you how great Signal is and how much better it is to visualize your stuff than Grafana. But actually, I'm not going to do that on this call. Come and join our community call, which is next week, and we'll do it. Sorry to cut you off. But yeah, that's
that I think that's a good point. Like Nica says, any Signals related questions you can get it join our Slack or get into community calls. If you have any specific questions about the OpenTelemetry, like let's say there is some pain point or it's at certain questions that you are not sure how to get help from, like this is the best place to ask and get help.
And to answer how they're similar, they're both ways to, in part, to visualize how you have some of the OpenTelemetry data that you sent. And so for the Grafana project, you're going to need some separate way to store that data. And there's a number of options for that. There's really cool stuff out there for Grafana. It's a very cool tool. So the specific different, the use case is similar for the visualization side. But yeah, they need to monitor AWS manage, Lambda API gateway with application services and use one part to visualize. So yeah, I do want to say there is ingest for AWS X-Ray for the collector. So you can send kind of all the data that you have to an OpenTelemetry collector, which can be hosted within your AWS cloud, and it can then send out to a storage and OpenTelemetry endpoint someplace in your system. And with an open source tool like Signals, you could run a Signals instance within your AWS cloud as well. So notably, right, like AWS is very open about their separations of concerns, right? So they don't want to be doing like application code monitoring. So it is going to make sense to use some kind of OpenTelemetry tool to monitor your application code and tell you what's going on there. Sorry, I'm going to show that question on screen because it's a great one. Sorry, did you have more you wanted to say about this one?
Yeah, I mean, I think you answered it perfectly. So if idea is to monitor AWS managed services like AWS Lambda and API with application service, and so this one you can, so that's the goal, one of the goals of the what we do. So you can with the OpenTelemetry collector, you can receive all the data from your application and then the AWS AWS specific services that are emitting the telemetry, such as container metrics, CloudWatch logs, and then you see all of that in Signals. So you have your own application metrics, your application logs, and the traces coming into Signals, and then the telemetry related the AWS services themselves, like container metrics and the as such. So they can be sent to the Signals as
well. Yeah, really, really great questions. Gosh, I love this community so much. I love that, I'll start it and I'll be like, oh, we might not get that many questions, might not get that many comments, because I've done a ton of observability live streams in the last 3 or 4 years. And, like you get people to view the videos. Not everybody, people don't always join the live streams and always ask questions. But every time we do one of these, we get all these great, really on point stuff. So that's just really, really nice. I really like that. So yeah, I'll share links to the AWS distro for OpenTelemetry and some of the ingester stuff down in the list below. Niraj has a final comment about Kafka. Would like to discuss a couple of the pain points. Feel free to join either the CNCF Slack to just discuss these general OTel things. We're both on there, or join the Signals Slack to discuss this, because monitoring Kafka with OpenTelemetry is absolutely something that is totally possible to do. You can get a ton of cool signals from that system with OpenTelemetry instrumentation. And that's like, you're not stuck then on a particular backend for where you send your data if you're doing the work to monitor it with OpenTelemetry. Okay, folks, this has been so good. I scheduled half an hour and we went a little bit beyond that, which I love because we had cool stuff to talk about. And we had really good questions. Oh my gosh, this is so great. But yeah, feel free to comment down below if you have more questions. We're happy to reply. Thank you so much, Srikanth, for sharing your expertise here. And let's go ahead and close it there. Let's want to be found someplace online. Do you want to share a plug? Do you have a SoundCloud album that you want people to check out? Srikanth, anything else?
No. So let us know, I hope this was helpful. Let us know if there is something that you would like to hear, do us a webinar. Let us know, join our Slack community channel, and let us know any topic or anything that you would like us to do on the webinar. Yeah. Thanks.
Fantastic. Thank you so much, everybody. We will see you next week.
Thanks, everyone.